Electric and hybrid electric airplanes. The electrification arrived on airplanes, and it's not necessary to go into details again about how important it is to the sector due to the high participation that fuel prices and technology have in the operational costs of an airplane. Despite electrification still have a lot to evolve since the current technology does not deliver as much volumetric energy density as conventional fuel, what we have available today are already capable to attend some small needs, as demonstrated by Pipistrel, the Slovenian company which was the first in the world to develop a 100% electric aircraft, the Taurus Electro, and is mainly used for training purposes. Further companies have directed their efforts trying to develop regional aircraft for short hauls in a range about 500 nautical miles, with the capacity for 9 passengers plus crew, as for instance Aviation Alice, that is performing runway tests and the first flight is expected to be in the next quarter. Aviation industries R&D today is mostly betting on detachable batteries, so that an electric airplane does not have to expend incredible amounts of time on the ground for charging, since technology today isn't capable of fast charging. This is the similar idea for most eVTOLs as well. The automotive sector was the first to increase the attention and consciousness about the advantages on electric propulsion, as well as demonstrate that real use requires much more from batteries and management systems than what they can deliver today. The sector has been on the lead on R&D investments for new solutions, and the efforts are intensive to find out how to increase reliability and volumetric energy density, and they have made great leaps every now and then. For instance, according to the Department of Energy's Vehicle Technology Office in the US, the volumetric energy density for lithium-ion battery, the better technology on mass production today, increased significantly since 2008. On that year, lithium-ion battery could store about 55 watt-hour-liter, and in 2020, the figure increased in almost 8 times to 450 watt-hour per liter. The 450 watt-hour per liter would be the best available today, but is yet to go into production. This mark was achieved by a startup in Michigan, US, called Our Next Energy, or ONE for short. They developed a dual chemistry battery, which divides the pack in 2 sections. One section is dedicated to power the engines, while the second is used to energy storage. This battery, called Gemini, uses 60% less graphite and 20% less lithium. Cobalt and nickel were also reduced, but the company didn't disclose the amount. The battery cells are different as well. They have a prismatic form. The cathode is used as a protective casing, and the anode is insulated and attached on one end. And all of it translates into weight reduction. Just for your reference about how advanced this technology is, the volumetric energy density for a Tesla Model 3 with 2170 cylindrical cells is 260 watt-hour per liter. The Gemini battery will equip BMW iX model at the end of this year. Further technology alternatives are being researched not only to solve volumetric energy density, but also to solve further problems such as charging time, overheating, and occasionally instant fire and so on. Of course, all this benefits aviation with the possibility of have better energy storage without changing the aircraft designs yet to debut and increasing its life cycle and operational capabilities. Embraer has not been standstill about the R&D related to this important alternative for fuel and operational costs. They envisioned aircrafts which would be able to operate in a hybrid configuration as well as 100% in electrical propulsion in one variant. To develop these airplanes was created a program called Energia, focused on the R&D for fuel-efficient solutions with efforts ranging from sustainable aviation fuel technologies, electric propulsion systems, more aerodynamic airframes to hydrogen technologies. Through the Energia program, Embraer created a timeline for the expected introduction of each concept in the market. The first airplane to be introduced will be a hybrid plane which will be based on the new turboprop with design changing in the wings and elevator. It will be called Energia Hybrid E9HE. The purpose here is to mix the better of electric and combustion technologies, and for a while this aircraft will be able to cover 500 nautical miles carrying 9 passengers plus crew, with 60% less noise than today's standard and 90% less CO2 emissions. As the disadvantages of full electric propulsion systems, which we've previously mentioned, are much more significant in airplanes than in terrestrial vehicles, Embraer decided to combine technologies in order to bring better range and payload, while it reduced significantly fuel consumption. The fuel in this application would be the environmentally friendly sustainable aviation fuel. 5 years later, in 2035, Embraer Energia aims to debut the first full electric airplane, the E9FE, a high wing with tail-mounted counter-rotating propellers capable of flying 200 nautical miles, carrying 9 passengers plus crew. Its design will be inspired by gliders, having a long wingspan for better lift and narrow fuselage at the rear. This concept is expected to be about 8% less noisy. This is the first and only full electric airplane in the hall of developments for the future. Of course, I'm not counting EV, the electrical vertical takeoff and landing vehicle, as it is on another category. Here, I'm only talking about airplanes. Possibly, as the battery technologies keep evolving, bringing much more volumetric energy density, faster recharging, less weight and more reliability, new full electric airplanes project might come from Embraer, and even the E9FE will have a better range by only replacing the batteries for a better and more advanced models. But let's take a look at further variants from Energia program.